Welcome back to Data Dive, the podcast where we explore the fascinating world of data storage and analytics. I'm your host, and today we're diving into the intricacies of database storage models. Specifically, we'll look at the advantages of column-oriented storage compared to traditional row-oriented storage. We'll also touch on multi-dimensional data representation and how it can enhance our understanding of sales data. So, grab your headphones and let's get started. Let's kick things off with column-oriented storage. If you're familiar with traditional databases, you know they typically store data in rows. This means that when you run a query, the database has to sift through entire rows of data, even if you're only interested in a few columns. This can be quite inefficient, especially for analytical queries that often require aggregating and summarizing large datasets. Now, enter column-oriented storage. In this model, data is organized by columns instead of rows. This means that when you run a query, the database can access only the columns you need, significantly enhancing performance. Imagine you're focused on sales figures for a specific product across various stores. With column-oriented storage, the database can quickly pull that data without wading through irrelevant information. But that's not all. This columnar approach also allows for efficient compression techniques. One popular method is bitmap encoding, which compresses data by representing it as a series of bits. This can lead to substantial reductions in storage space, making it a win-win for data warehouses that handle massive amounts of information. You might be curious about CPU efficiency as well. Column-oriented storage shines here too. It enables vectorized processing, which allows the CPU to process multiple data points simultaneously. This parallel processing capability can lead to faster query execution times, especially for complex analytical tasks. However, it's not all sunshine and rainbows. While column-oriented storage dramatically improves read performance, it complicates write operations. When you need to insert or update data, you may have to rewrite entire column files. This can be a significant drawback in environments where data is frequently changing. To tackle this challenge, many systems implement structures like LSM trees or log-structured merge trees. These trees manage in-memory writes, allowing you to quickly insert or update data without immediately rewriting the column files on disk. Once the in-memory data reaches a certain threshold, it's merged with the column files, ensuring that the system remains efficient even during heavy write operations. Another technique to enhance query performance in read-heavy environments is the use of materialized views. These are essentially cached results of complex queries, stored for quick access. By pre-computing and storing aggregate results, materialized views can save time and resources when you need to run the same queries repeatedly. This is particularly useful in analytical scenarios where users often request similar reports. Now, let's shift gears and talk about multidimensional data representation, specifically using a 5-dimensional hypercube to illustrate sales data. Picture this. You have sales data categorized by date, product, store, promotion, and customer. Each cell in this hypercube contains sales figures for specific combinations of these dimensions. This structure allows for efficient summarization of data without the need to scan through large data sets. The beauty of data cubes is that they enhance query performance for specific analyses. For example, if you want to know how many sales were made for a particular product during a specific promotion at a certain store, a data cube can provide that information quickly and efficiently. However, there's a trade-off. While data cubes are fantastic for certain types of queries, they lack the flexibility of querying raw data. This limitation means that if you want to perform calculations involving non-dimension attributes, like determining the proportion of sales from high-priced items, you might find yourself constrained. The structure of a data cube is designed for speed and efficiency in specific scenarios, but it can't always accommodate the more complex queries that raw data can. So, to wrap it all up, column-oriented storage is gaining traction in the world of data analytics, especially for handling large data sets and complex queries. Its ability to enhance read performance, facilitate efficient compression, and improve CPU efficiency makes it a compelling choice for data warehouses. However, the challenges it poses for write operations are significant, and solutions like LSM trees and materialized views help mitigate these issues. On the other hand, multi-dimensional data representation using structures like hypercubes offers a powerful way to analyze sales data across various dimensions. While they excel in performance for certain queries, they do come with limitations in flexibility, particularly when it comes to more intricate calculations. That's all for today's episode of Data Dive. We've explored the advantages and challenges of column-oriented storage and the intriguing world of multidimensional data representation. As data continues to grow in complexity and volume, understanding these concepts will be crucial for anyone working in analytics or data management. Thanks for tuning in. If you enjoyed this episode, don't forget to subscribe and leave us a review. We'd love to hear your thoughts and any topics you'd like us to cover in future episodes. Until next time, keep diving into the data.